Okay, there's three ways to prove triangles are similar. If they're similar, that means they are the exact same shape. They're just different size. If you have two pairs of congruent angles, so angle theorem, or if you've got three sides, like this right here, this is what they're saying, side similarity. Or if you have a pair of sides with a pair of congruent angles in between. So number one, C, because you have a pair of congruent angles. Angle L matches with angle C, but angle K is a vertical angle with angle K. These two are congruent. So if these two match up, these must also match up. So K is going to match up with K, L is going to match up with C, and M is going to match up with D because of the angle similarity. Okay, number two. Don't fall for this trick. It's going to be B or D. You've got to set up a fraction. If you choose 32, 32 is the smallest. So I got to compare 32 with 24. And then that means I got to compare 40 with 30. What, Dakota? I think so. So it's going to be like this. Your test is going to be like this. Now these two fractions are going to be the same. This will give you the same ratio. So now the trick, Dakota, you got to match up J with C. K, what one's going to match up with K? How come K matches up with D? Because they're both on the smallest. It goes C to D, that's the smallest side. J to K, that's the smallest side. So this has to be E. So make sure you get the order right. Don't mess up the order. Okay, this one. You guys send in an answer. Okay. You got to find the biggest side. And you got to pair those together. So you can do 23 to 156, or you can do 156 over 23. It does not matter. But if I do 23 over 156, now I have got to follow. My next is the middle one right here. 18 and 117 are the two middle ones. So you got to match up 18 with 117. And then the two smallest, you got to match up 16 with 104. And now you got to punch these three in on your calculator. If they are all three the same decimal, then they will be similar by the SSS similarity theorem. But if one of these is not the same as the others, we're going to go with D. They're not going to be similar. You got to set up some fractions. So let's set up a fraction equal to a fraction. So they tell you the triangles are similar. If the triangles are similar, I'm going to compare 55, and you can compare 55 to 50, or you could compare 55 to 99. I mean, there's a lot of fractions you can set up, but now if I choose 55 to 50, this is the side I need to find. So I'm going to compare 99 with X. And now if you have a proportion, you're going to cross multiply and solve for X. So it's going to be 55 multiplied by X is equal to cross multiply this way. 99 times 50. Then solve for X. Divide by 55. Divide this side by 55. And you should have X gives you a 90. Alright. Okay, this one is kind of slick because it's an isosceles triangle. but we're not even gonna use the shortcut. We're just gonna do the fraction, because the one on the test, they're probably not gonna both be 10. Because look, if this is 10, this is 10, that's 20. This has to be 20. And so what number plus 6 is gonna give you 20? It's gotta be 14. But the algebra, if you're gonna compare 10 to 10, then you gotta compare 20 to x plus 6. And if you cross multiply, you're going to get 200 equals. Now when you cross this way, you got to times the 10 to both of them. 10 times the x is 10x. 10 times the 6 is 60. Now solve for x. So minus 60 minus 60. So we got 240 equals 10. Or we don't got 240. We got 140 equals 10. X divided by 10 divided by 10. So x is going to give you 14. Alright, cosecant. So for move number 1, you got to figure out what the fraction is for cosecant. Cosecant matches up a sign, so it's going to be hypotenuse over opposite. And I'm going to make my 90-degree triangle. So on my terminal side, I put a point and go straight down to the x-axis. So there's my 90. So here's the triangle I'm looking at. 30, 60, 90. I'm going to make up my own dimensions. And I know the other half of this triangle looks something like this. So I'm going to choose 2, 2, 2. So I know each of these little sides are 1 because they get cut in half. And this altitude is going to be 2. It's not going to be 2. It's going to be the side that gets cut in half times the square root of 3. So I know in this triangle, this is my hypotenuse, this is my opposite, and this is my adjacent. Because you're looking from the origin. This is where you're looking from right here. So now the hypotenuse is going to be 2, and my opposite is 1. So 2 over 1 is 2. The cosecant, we just barely did that, so that was hypotenuse over opposite. Okay, negative 60, so I'm going to draw and go straight up to the x-axis. And if this is 60, this is 30, so I know the other half of my triangle, it's an equilateral. So I'm going to go 4, 4, 4. Then this is going to be 2, and this is going to be 2. And I know this altitude right here is going to be 2 square roots of 3. But it's going to be negative 2 square roots of 3 because I'm going down. So now I'm going to draw kind of a bigger picture. If I'm looking from right here, and there's my 90, I know this is my hypotenuse, I know this is my adjacent, and I know this is my opposite. So I want the hypotenuse, which is 4 over the opposite, which is this guy, negative 2 square roots of 3. And now I'm going to simplify 4 halves. 4 divided by 2, that's the same as 2 over a negative square root of 3. And I can't have a square root on the bottom, so I'm going to times this by square root of 3. I'm going to times this by square root of 3. So at the end of the day, you should end up with 2 square roots of 3 on top, and we've got a negative square root of 9 on the bottom. Square root of 9 is just 3. So you should end up with 2 square roots of 3 over negative 3. Alright, now you got one that's going to get complicated. Cotangent matches up with tangent, and I know tangent's opposite over adjacent, so this one's going to be adjacent over opposite. So now I'm going to start subtracting circles. So I'm going to do 10, 20 minus a circle. And that is going to leave me with 660, which is still too much, so I'm going to subtract another circle, which should leave me at 300. Okay, 300. So if I rotate 300 degrees, alright, 300 degrees is the exact same as 1020 degrees. So if I rotate 320 degrees, each quadrant is a 90. So if I start here and go 90, 180, 270, 300, and then that means this is going to be 60. Because 300 and 360 is a full circle, so I've got to go 60 degrees to get to a full circle. So now my triangle, there's my 90, there's my 30. So if it's 30, 60, 90, I'm going to say this is 2, this is 1, this is 1 times the square root of 3, but it's negative. And then I want adjacent over opposite. So this one is my adjacent, this one is my opposite, this one's my hypotenuse. So I want 1 over a negative square root of 3 times by square root of 3 on the bottom times by square root of 3 on top. So it's going to be square root of 3 over negative 3 for my fraction. And number 9, sine. The fraction is pretty easy. Opposite over hypotenuse. But there's too many circles, so I'm going to start taking away circles. So I went 945. I'm going to take away 360. 945 minus a circle is going to be 585. I'm going to minus another circle. 585 minus 360. Okay, 225 is what I want. But I'm going in the negative direction, so it's negative 225. So here is a negative 90. Here's a negative 180. So how much beyond 180 did I go? So I'm going to do 225, take away 90 and 90, take away 180. So 225 minus 180, and it should give you a 45. So the angle you're looking at right here is a 45. So I'm going to make a triangle, go down to your x-axis. This is 45. I know 45 is half of a square. So I'm going to use whatever I want. If I say that's 1, that's 1. This is going to be 1 times the square root of 2. And if I'm looking from right here, I know this is going to be my opposite. This is going to be my adjacent. And this will be the hypotenuse. But because I'm going left, I need to make that a negative 1. So now, the opposite over hypotenuse, I want 1 is my opposite. My hypotenuse is square root of 2. And I can't have a square root on the bottom, so I times by square root of 2 times by square root of 2. On top, you should have square root of 2. On bottom, you should have square root of 4, which is just 2. Okay, now, these ones are actually easier. So all you gotta do is find the missing side lengths. We want to know what A is and what B is, and the 30 is the hint. So if that's 30, this is 60, and I know the other half of my triangle looks just like this. So if this is 3, this must be 3, so that must mean each length is 6. So A has to be 6, and B is going to be 3 square roots of 3. 45 is the hint, so it's half of a square. Here's my other half right here. This one's hard though. If this is 6, I know that if I had this, I times it by square root of 2. So I'm going to go backwards. I'm going to take 6 and I'm going to divide by square root of 2. But I can't have square root of 2, so I'm going to times square root of 2 on top, square root of 2 on bottom. So it's going to be 6 square roots of 2 over 2. And 6 divided by 2 is going to be 3. So x and y both are the same, and they are both 3 square roots of 2. Okay, if that's 60, that's 30. That means the other half of my triangle is right there. This one's tough too because they gave me the altitude 9. I usually take this and times it by square root of 3. So I'm going to go backwards. I'm going to do 9 divided by square root of 3. So times the top by square root of 3 times the bottom by square root of 3. I got 9 square roots of 3 over square root of 9. which is 3. So 9 divided by 3 is 3 square roots of 3. So that's what n is. And to find m, I'm going to double that. So I'm going to times it by 2. And that means m's got to be 6 square roots of 3.